I'm going to do a neutralization reaction. On the left, I've got hydrochloric acid, and we're going to check this by checking the pH. And on the right, we've got sodium hydroxide. All right, so this is my acid and my base. And we also recall that we can verify the presence of the OH group by using a drop of phenolphthalein. So here I've got my phenolphthalein. My idea here is to mix the two, and the way I'll know if it's totally balanced is that the pink color of the phenolphthalein will dissipate. I will have reached a balance when my phenolphthalein will just disappear. Okay, so I'll try another drop. No, I won't try that. I'll try some sodium hydroxide. And I see that by adding a little bit more, because sometimes I'm just a few drops off. I've got the same molarity of both. I've got 0.1 molar of sodium hydroxide and 0.1 molar of hydrochloric acid, but the pipettes can be tricky sometimes. They will take on a little bit more than the other one. So it's quite normal to not have it perfect. In advanced chemistry, we call this titration. When the pink, just about, like here, I'm about 2 drops extra on the on the sodium hydroxide, and I will add 2 more drops of hydrochloric acid, and hopefully that will balance. I'm going to go to another container here. Make sure that, there we go. Now, I've neutralized. I have balanced it. And what I do, we try to figure out what I have, and let's fast forward to tomorrow. And I notice that the liquid has evaporated, and I end up with a crystallized substance. Okay? And sure enough, I'm not going to taste it, but I will find out that it's water that evaporated, and I am left with salt, NaCl. So this reaction, the sodium grabs onto the chlorine, and we get sodium chloride, plus the hydrogen grabs onto the OH group, and we've got water. And if you check, you've got the same amount of hydrogens on both sides, oxygen, sodium, chlorine, you're balanced. And this is your neutralization reaction.